Chapter 12, we also are doing hypothesis testing, but our data is different now. Our data is no longer numbers. Our data is going to be text. And we want to know if two factors are related or not. So what we're interested for this one is that we want to know if people's preference for cola is related to their preference for sweetness. So we ask people questions, and we says, hey, which cola do you like? And then do you like sweet stuff? And so we gave them, and so you can see these numbers aren't numbers. They're just categories. So when we have categories, the only thing that we can do is count. So the formal thing that we're doing is that we're going to do a test for independence, and we're going to use a statistic called a chi-squared stat. We're going to wind up using a pivot table to create these contingency tables, these two-dimensional tables that has so many rows and columns, and then we're going to take that data and calculate what we expect to get if they were independent. Now that's a pretty complicated formula. I'll show you how to do this in Excel. It's not hard. Once we have everything we have, we need to be able to calculate the chi-squared statistic. Again, this formula looks a little bit complicated. I'll show you how to do this in Excel. And then the most important thing is that we're going to be able to calculate a p-value directly from an Excel formula. So let's do an example. As I mentioned, we've got data where we've asked people questions, and the answers aren't numbers, they're categorical. So the first thing we need to do is be able to relate or count how many people preferred this and how many people preferred this. So I'm going to use a pivot table to do that. And I'm going to go grab the data, and I'm going to let it generate a new worksheet. And I'm going to drop cola preference into one, and I'm going to drop sweetness preference in the other, and then I'm going to drop one of these into the, cola preference into one, sweetness preference into the other. So there's my data. I'm going to copy it. I'm going to go back to my original, and I'm going to put it here. Okay, so I'm going to give it, this is what actually happened. This is what we observed to happen. The number of people out of the 40 who said they like this and then didn't prefer anything sweet were 6 people. The total number of people who preferred this were 16. The total number of people who preferred this was this. The total number of people who like things really sweet is this. So these are the totals of the sweetness. These are the totals of the cola preferences, and then these are the crosstabs, counting how many people that like this and like this. And I want to know if these are related. So I'm going to grab that. I'm going to copy it. I'm going to go down one row and I'm going to paste it, and I'm going to replace this observed with expected. And I'm going to get rid of all these, and I'm going to use a formula to calculate it. The formula that I'm going to calculate it is based on this. Okay, now I'm going to show you how to do this in Excel. For every one of these 6, so for every one of these, it's going to be the row total times the column total divided by the overall total. So this is column 1, row 1, so I'm going to go to row total of 1 multiplied by column total of 1 divided by the overall total equals this times this divided by this. I'll do it again, one more. So this is now row 1 multiplied by column 2 divided by the overall total. Now you could do this over and over and over, but here's what you should do. You need to go and put dollar signs in front of this. So I'm going to put a dollar sign in front of this K because I want to lock it in. And I'm going to put a dollar sign in front of this row 17. And then the bottom one, I'm going to put a dollar sign in front of both of them. So look at that format, because you're going to use this every time. And I'm going to copy this to the right, copy it down. This is what really happened. This is what I would expect to happen if they were independent. Expected if independent. So you can see there's a difference. There might not be a lot of difference, but there's a difference. So now we need to calculate the chi-squared stat. So I'm going to grab all this again. Actually, I'll start with this. Grab all this, go down, And now I'm going to calculate the chi-squared stat. The chi-squared stat. How am I going to do that? How you're going to do this is that we're going to look at this. And we're going to look at the difference between what we observed, the actual frequency, and what we expected, square that divided by the expected. Equals what we observed minus the expected. We square that divided by the expected. Take that number, copy it for all 6 combinations. There you go. So my chi-squared then is the sum of that. The chi-squared is add those up. Add up those 6 values in this case. Okay. Now we have a chi-squared. Now we need to calculate the p-value, and that's real easy. There's a formula in Excel that does this for us. It's called the chi-test. We bring in the actual range, and you got to bring in what you observe first. Actual and observed, bring these in first, then bring in the expected. And notice I only grabbed the 6 values. I didn't grab any totals. There's your p-value. Now we compare p-values. Since the p-value is greater than alpha, we fail to reject H0. For this problem, our p-value is bigger than alpha. That means that the chances, the likelihood that that's true is pretty high. So we don't want to reject it, so we fail to reject it. And so it says that they are independent, so we said that cola preference is not related to sweetness preference. Okay, that is doing chi-squared test of independence in Excel.